In this lesson, we are going to learn how to come up with the algebraic rules for the three main reflections and the three main rotations without having to memorize any rules. So take you a sheet of graph paper, turn it into 6 sections. You can do that by folding in and then folding and then fold long ways. Okay, draw your 6 coordinate planes. And then I'm going to do the top 3 as your reflections. I'm going to do the bottom 3 as your rotations. So the first algebraic rule we're going to come up with is a reflection over the x-axis. So what I like to do is I like to start with a point. It needs to be an easy point, but it also needs to be a point that has a different x value and a different y value. So reflections, you have to have a line of symmetry. So in this situation, our line of symmetry is our x-axis. So if I'm going to be reflected or flipped over this line, I have to be equal distance from this line. Because as you learned, lines of symmetries are perpendicular bisectors when you flip the points and you draw a segment from one point to the other. So bisect means I cut in half. Equal distance. So in this situation, notice how I'm 1, 2, 3, 4 units above, so I have to be 4 units below this line. So now my new point is located at -1, -4. When I draw my line to connect these 2 points, not only do you bisect, but also you're going to be a perpendicular bisector. Perpendicular means a right angle. So here's my right angle. And again, I'm bisected because 4 and 4. The line is the x-axis, the symmetry line is halfway between this segment. Okay, so now how to come up with the rules. So I start by writing my original down. So -1, 4 becomes -1, -4. So if I look at the 2 points, one thing I want you to notice, I'm still using the points 1 and 4. Those values never did change. It'll magically become something else. Now the signs can change, the position that they're in could change, but the actual 1 and the 4 itself is not going to change. So notice how my x did not change. So I have the same x, and I'm going to write this one as xy because that's my original. And so my x didn't change, so it's the same x. But notice how the signs changed on the y. So it's opposite y, and that's going to be -y. This algebraic rule is going to apply for every reflection over the x-axis, no matter where the original point is located. The x value won't change, but the y's are going to change signs. So now let's look at a reflection over the y-axis. So again, I'm going to start with the point -1, 4. I want to label it. If I'm flipping over the y-axis, the y-axis is my line of symmetry. So again, perpendicular bisector. I am equal distance away from the y-axis, so I'm 1 away here. So I need to be 1 away over here. So now my new location is +1, +4. And I'm going to draw that line so you can see the segment, and you can see how it is again a perpendicular, the y-axis is a perpendicular bisector. It cuts this segment in half. So now to come up with my algebraic rules. So to start with, I've got my original, -1, 4. And it become +1, 4. So my original is always going to be x, y. And so how did it change? Well, again, notice how in none of the values changed. I still have a 1 and a 4. Signs could change. They could flip-flop. But again, notice how my y is the same y. But notice how the sign's changed on my x. So what is that rule? The rule is opposite x, y. This is the algebraic rule that's going to work for all of your reflections across the y-axis, no matter what point you start with. If you want to try a different point, let's come up with one in the negative quadrant. So maybe I could take the point -4 and -2. So if I'm -4, -2, I would be located right here. So if I apply the rule, so the rule is opposite x, so +4, same y, so -2. So I'd be located right here. Okay? So you can always apply it and see if it's working, but it is for sure. All right, now our last main reflection, and the last reflection is the reflection over the y = x line. So for this one, I want to start off by graphing the y = x line. So y = x, I have a y-intercept of 0 and I have a slope of 1. So I'm going to graph that line. And so this is going to be the bisector, the perpendicular bisector. It is going to cut in half the segment that's made between those 2 points. Now, when I choose a point for this one, I want to choose a point that's easy. It needs to be a point that's sort of close to this line. It also needs to have a different x and a different y. So I'm going to choose, instead of being in the quadrant over here, I'm actually going to be in this quadrant here, and I'm going to choose the point 1, 4. So what I'm going to start with is I'm going to start by creating a line that is going to be perpendicular to the y = x line. So to be perpendicular to this line, then you've got to think about the slopes. So this one has a slope of +1. So to be perpendicular, your slope has to be opposite reciprocals. What does that mean? Take your slope, flip it, and change the sign. So +1, if I flip it, it's, well, 1/1, it's still going to be 1/1, but then change the sign, -1. So what I'm going to do is I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. I mean, you can put several points and graph that line. Whoops. And notice how lightly I'm doing this. Very lightly. So one of these points that's on this line that I just graphed is going to be the perpendicular bisector. So do you see our right angle? I indeed have my right angle. If you're not sure, take a Post-it note, stick it to see that you've got the right angle there, which we do. Okay, and so then now the second part is the bisect part. Bisect means cuts in half, equal distance. So I'm going to look at my diagonal lengths here. Notice how I'm a whole diagonal and a half diagonal. So I need to be a half diagonal and a whole diagonal. So where does that point have to be located? Right there. There is my point of reflection. So where am I located at? I'm located at 4, 1. That point had to be it because, again, notice how you still see the 4 and the 1 and the 4. You see, this point right here is the point 3, 2. That changed. This point right here is the point 6, -1. Those, 6, -1. Do you see how those values are changing? We don't want the values to change. We still want to see the 4 and the 1. So Now I've got my point of reflection. How do I write that as a rule? So I started with the 0.14 and it became the 0.41. So what happened? Well, x, y flipped-flopped and became yx. That rule is going to work every single time if I reflect over the line y equals x. If you want to, you can test it to make sure. But xy will always become yx when I reflect over the y equals x line.